Chapter 2, Section 1. We're going to take a look at one-step equations. The two one-step equations that I want to look at is called an additive inverse or a multiplicative inverse. The multiplicative inverse can also be talked about as the reciprocal of the number. We've worked on multiplicative or reciprocals before. All right, so this should be kind of a review from you from Chapter 1. Let's take a look at the additive inverse. When we add two numbers together, we should always come up with the sum, or the additive, the sum should always come up to 0. In a multiplicative inverse or reciprocal, when we multiply the reciprocal by a number, this should always come up to 1. So an additive inverse should always equal 0 when we add the one number to its inverse, and when we multiply the reciprocal of one number to the other, then that should come up to 1. Let's take a look at what this looks like. First, the additive inverse. Additive inverses look like this. Let's say we have the number 3, and we want to add its inverse to that. We take the negative of that number, in other words, negative 3, and add it to it. So 3 plus a negative 3 equals 0. Remember, additive inverses have to equal 0. Another example might be a negative 5. What could we add to a negative 5 to make it 0? Well, we add its additive inverse. Additive inverse in this case is 5. Negative 5 plus 5 equals 0. These are additive inverses. If it doesn't come up to 0, so if we had, let's say, 3 plus a negative 4, is negative 4 the additive inverse of 3? Well, no, because this actually equals negative 1. It doesn't equal 0, so this here is not an additive inverse. Next, let's take a look at the multiplicative inverse or the reciprocal. Remember, when we use the multiplicative inverse and we multiply it by its original number, this should equal 1. What are some examples? Well, let's say I had 3/4 and I multiplied it by its multiplicative inverse. What would the multiplicative inverse be? Remember, this is review from Chapter 1. We're going to take the denominator, put it in the numerator, and take the numerator and put it into the denominator. And we multiply this through. 3 times 4 equals 12. 4 times 3 equals 12. 12 over 12 equals 1. If that's the truth, if that's correct, then 3/4 and 4/3 are multiplicative inverses or reciprocals of each other. What would be another example? What if we had 5? What would be its multiplicative inverse or its reciprocal? Well, if you remember, 5 is actually can be written as 5 over 1. All right? So if we take 5 over 1 and do the reciprocal of it, it's 1/5. Now 5 times 1 is 5. And remember, this 1 is sitting down underneath that 5, and 1 times 5 is 5. 5 over 5 equals 1. That is a multiplicative inverse. Last, let's do some examples. What if we were to let's look at number 1 right here. Circle the additive inverse of 6. What would be the additive inverse of 6? Is it negative 6, negative 1/6, 1/6, or 6? Remember, additive inverse, this has to equal 0 when we add them together. So 6 plus negative 6 equals 0. Negative 6 would be the additive inverse. Let's take a look at number 2. Circle the multiplicative inverse. Remember, the multiplicative inverse has to equal 1. So what will we multiply 6 by to come up with 1? Will we multiply it by negative 6, negative 1/6, 1/6, or 6? Well, if we take a look at what would be the reciprocal of 6, we would recognize right away the reciprocal of 6 is 1/6. So that would be the multiplicative inverse. Now that we understand the arithmetic inverse and the multiplicative inverse, let's take a look at one-step problems. Let's use this for an example. X plus 5 equals 33. What we need to do is we need to solve for x. Now, you're going to hear this a lot. Solve for a variable. In this case, solve for x. What we want to do is we want to get x on one side of the equal sign by itself. In other words, we want it to look something like this. X equals some number. Okay? In this case, if we look on this side of the equal sign right here, we see that it's x plus 5. What we want to do is we want to get rid of this 5 right here and just have x alone on this side of the equation. Well, remember the additive inverse? Well, the additive inverse of 5 is what? Negative 5. So we're going to put negative 5 right here. But whatever we do on this side of the equal sign, we also have to do on this side of the equal sign. So if we have minus 5 there, we have to put minus 5 here. If we solve this now, x comes down, the 5's cross out, and 33 minus 5 is 28. We now have solved for x. You'll hear that term. Solve for a letter, solve for x. In this case now, x equals 28. Let's take another one for an example here. Let's say we had x minus 2 equals 10. What is the additive inverse of minus 2? Remember, we want x by itself on this side of the equal sign. So what we'd have to do, additive inverse of 2 is 2. So whatever we do on this side of the equal sign, we have to do on this side of the equal sign. So if we added 2 here, we have to add 2 here also. We'll find the solution to it. X comes down. Minus 2 plus 2 is 0. We don't have to write that in. We've got equals here. 10 plus 2 is 12. We now know that x equals 12. All right, let's try another example. This last example, we used the additive inverse. Let's see about the multiplicative inverse. Let's say we had x over 5 equals 12. Well, again, we want to get x by itself on one side of the equal sign. What will we have to do to get x by itself? If we look at our fraction here, x over 5, what is the multiplicative inverse? Well, this can also be written as 1/5 x, correct? Equals 12. Because there's really a 1 times x up in front of this. So we can write this as 1/5 x. What is the multiplicative inverse of 1/5? Well, we know that as 5 over 1 or 5. So we can write this as 1/5 times 5x. And remember, whatever we do on one side of the equal sign, we have to do on the other. So we multiplied by 5 there. We have to multiply by 5 here also. And in this case, 1/5 times 5 equals, what's multiplicative inverse? It makes it 1. So we're just left with 1x or x on one side, and we're left with 12 times 5, which is 60 on the other side. We have our answer. Let's try that one more time. Let's say we have 5x on one side equals 20 on the other side. Well, what's the multiplicative inverse of 5? We know it is 1/5, right? So we can say 5 times 1/5 x, and whatever we do on one side, we have to do on the other. So we'd go 20 times 1/5. Well, 5 times 1/5, when it's a multiplicative inverse, we know this goes to 1. So we can put a 1 out in front of the x, or we can just leave it as x. 20 times 1/5 would be 20/5, right? Remember what I told you in chapter 1. This is just like saying 20 divided by 5. What's 20 divided by 5? Well, we know it is 4. And that would be our answer.